our company are not particularly low carbon experts. We certainly don't have a stand here, so you may be wondering why I'm here at all. And we're a company that sells a generic solution called Geographic Information Systems, which I'll come on to talk about. And they're used across all sorts of domains and markets, from planning where Tesco put their next store to where they deliver their home delivery groceries, to managing National Grid's gas network, to local authorities approving planning applications. They're used across a whole range of areas. And we feel, through some case studies we've done recently, and some work in particular with Nottingham City Council, that the use of the GIS, as it's called, is just as applicable in this sort of low carbon renewables area as well. So that's what I'm going to cover today. And if I can get this to move on. You'll know more about this than I do in terms of the low carbon economy and what you've got to achieve by when and how you might achieve that. And on this slide, the key things here, without getting into the detail, are where things are and, where's the supply, where's the demand for the different types of energy mix that is going to come along and needs to come along in the future. And there's different angles of looking at this as well, from local government to an energy retailer, etc. Those different types of stakeholders across the top. You've got to, at a macro scale, and this is where I'll come on to talk about this, produce a strategy as to where you're going to invest in renewable technology, low carbon initiatives. You've got to assess the cost, the effort and the risk, as I'm sure you're aware. You'll need to do a financial appraisal. You'll need to consult with various people on this and what you're planning to do, and you'll need to publicise what you plan to do as well. Now, in order to do all that, you, as I'm sure you're aware, again, you need an evidence base, and there's buzzwords around at the moment around evidence-based decisions. And we feel we've got some tools and approaches that will help you in bringing together the evidence that you need to help plan the rollout of these sorts of technologies. As I said already, you probably know very well already with the existing business systems that you've got, the who and the what and the when, but maybe you don't make the best use of the where within the routine data that you collect and the information you handle on a day-to-day basis. So the geographical approach, which is what I'm talking about, is all about the where element here. Has anyone heard of the term Geographic Information Systems before, or GIS? One or two. So it's what I thought. We're well known in the markets we deal in, but maybe not well known in this sort of market. And what I wanted to do is a very quick, brief overview of what GIS is. And you typically have, as I've mentioned, business systems within your organisations that collect all sorts of information in spreadsheets and databases and CRMs and all sorts of systems like that. You typically have the use of background mapping, whether it's through Google or Bing or Ordnance Survey. And you'll have map-based information, whether it be push-pin maps on the wall or paper maps put up as well. And what a GIS is, in its generic sense, is the ability to take that information, which is geographical inherently in terms of addresses or postcodes or unique property reference numbers or assets IDs, policy zones that you might have or catchment areas. They're all geographical in nature, and you take that for granted. You don't really think about it, I'm sure. And what we can do is bring that information together in a series of layers that can be overlaid on top of each other in its simplest form and displayed in the sorts of software that we have available to help you to analyse information in a way that you simply can't do using traditional database and spreadsheet techniques. You can look at relationships between data spatially. So is one point inside another area? How far away is this thing from another thing? How far does it take to travel from one point to another? All these sorts of geographical questions. And we can take that and we can produce, like you produce your general business intelligence on a day-to-day basis, we think we can add the geographical element to that. And just to illustrate that a little bit further before I get into the detail of the low carbon side, is in terms of where GIS is in this slide, this picture. Well, as you might guess, it's used all over the place in terms of managing the sorts of things that have to be managed in this sort of a landscape, from tourism to your gas and electricity supply networks to your facilities management and the parks and recreation. It's used all over. So how can a geographic approach help in terms of where you target at a macro, but going down to a micro scale if you want to, low carbon initiatives? How can you analyse that, produce an evidence base, and then disseminate that information back out to the people it needs to go back out to? The approach we've taken on a case study, which I'll come on to, is to take property level information. If I can just bring the mouse up here. So down at the bottom here we've got address-based data, or in the case of councils, a local land and property gazetteer, or a gazetteer of any kind that lists the properties in your area, your catchment, or whatever it might be. And we want to get to an enhanced property level intelligence. And what we do, as I said right at the start, we're not experts in low carbon, but what we do is work with experts such as the Building Research Establishment, BRE. We've had some input from UCL or from Experian as well. And they can bring along their own models, their own data, and we can bring all that together by using GIS. And we bring in sorts of models that allow you to predict where the best places are to locate or potentially locate medium-scale wind turbines, to predict where the energy demand is coming from the domestic market and from the non-domestic market, and also to analyse the solar potential for roof space within your area using some models that we have, which we've had around for years, and we're only really just beginning to make best use of them now, which geographically analyses the location of the building, the aspects of the roof, etc., and the potential solar gain that will be made on that building. We then take all that information from a property level, and we can look at it at a property level, as you'll see in a minute, but we can also amalgamate it up to different areas, to say ward or to district or to your catchment areas, and look at the same data but just in different ways. And ultimately, therefore, you move from the usual scheme of having data, turning it into information, and ultimately knowledge. So some examples from Nottingham, and what we looked at there was solar potential, medium-scale wind, and the energy efficiency and energy demand. And the sorts of things we can do is to take, working from the top down here, is there's lots of commercially available data sets out there that plots very accurately the height of buildings and trees and the urban, any landscape really. It's typically called LiDAR data or similar sorts of data. And we can take that very raw, very voluminous data, and we can analyse it, and we can create a digital height model using our solutions. And then off the back of that height model, once we've got it there, we can begin to derive the aspect of a roof, the slope of the roof, and the area of a roof. And then we can add on top of that our solar gain models as well. And from that, at a property level, we work out the potential solar that roof will receive. In terms of medium-scale wind, we also do large-scale wind as well in terms of planning large wind turbine sites. But this is looking very much at sort of, as you might guess in Nottingham, smaller potential within urban areas. We take a wind surface speed map and we overlay that with areas we don't want to be too close to road networks. We cut those out using different map layers. We also take away the distance from existing properties. We don't want these turbines to be too close to existing properties. We can, what we call cookie cut that data out. And we also want to make sure we're outside of any recognised planning constraints. And we layer that information into the system as digital maps and then overlay that on top of each other and cut out the areas where we can't do certain things and leave the areas where we might be able to do something. In terms of energy efficiency and energy demand, what we do there is we take information on property type. We again build in a height model to work out the potential volume of the buildings. We bring in a gazetteer, or in this case the local land and property gazetteer, information on property age and tenure, and we also bring in the expertise from people like BRE to help work out what the best low-cost, low-energy inputs are to put on these types of buildings. And we process all that information, and one of the outputs from it is a spreadsheet, and that's quite useful to some people. It's, in this case, a list of properties and the area of the roof and the potential roof space there might be for solar panels, and then some derived information on the potential payback time, etc., and feed-in tariff rates as they were at the time when this work was done, and also ultimately the potential CO2 savings. And finance people think that's great, that's good, they can analyse that and use it in the various models that they have. But we also have another way of looking at it as well as a geographical approach, which is to look at it in map-based form. Now these look obviously just like bitmap images, but they're actually interactive map layers that you can go on and interact with, zoom in, zoom out of, and go right down to properties level. The properties are colour-coded according to the information we want to try and show. In this case, it might be a red, amber, green type map on the solar potential for those properties. So for a city like Nottingham, for example, you can analyse the tens of thousands of properties that are there. You can zoom right out to city level, or you can zoom right into property level to see the same sort of information, but displayed in different ways. We can also help to identify, it's a bit difficult to see on here, if I can get the mouse back up, these grey areas are the areas that are left with the small-scale wind turbine analysis I was mentioning before. So these are potential areas. We're not saying these are definitely areas you can go and install turbines in, the smaller turbines, but they're potential areas. If you're given a blank starting point, which is the whole of a city, where's the best place to start to go and look as to where you might target areas for investments, in this case around medium-scale wind, and we help to prioritise the areas that you might want to go and look at, and then you bring your own expertise, your own local knowledge into those areas as to whether they're suitable or not. But we sort of give you a good starting point as to where to go. In terms of energy efficiency and energy demand, we can look at the data again at individual property level, how much, what's the likely energy demand from this sort of property, and view that at property level. We can also take that same information and create hotspot maps from it. So it's the same data, but it's displayed in a different way. So you can begin to see maybe slightly different patterns that are there in the data that aren't obvious in looking at it in one way as they are when you look at it in another. So around this area, again, it's an interactive map if you were to be viewing it in the solution. You could see where the energy demand is, and it can help to target where you might invest, for example, in a combined heat and energy plant, based on where the demand is and where the sources for the potential demand might be. So that's very quickly going through how you can analyse and bring together data to start target where you might invest in low carbon. But how are you then going to publish that back out to different audiences that you might have? You'll have your expert audience, but you also have your maybe general public audience as well. And we devise systems that can also publish information back out. Sorry, what I didn't mention is the sort of questions that Nottingham were looking to answer off the back of this was in terms of evidence-based decisions is, where's the best places to invest in solar panel across all that housing stock that they might look after, the tens of thousands of properties. What's the potential to generate income from the feed-in tariff? What's obviously the usual sorts of questions, what the likely payback time? And this is a model, it's not going to be 100% accurate, but it's a good starting point to begin to focus in on certain areas that you might want to look at. And you can read the other types of things that we can help answer there as well. There's a few screenshots here of the site that Nottingham put together, and it's on their, this is Nottingham City Council, it's on their standard website as a council. And they've got the Nottingham Energy calculator, a lot of publicity going on around this at the moment. So underlying this very simple application is that very complicated data that you've seen, which can be thousands of rows of data in a spreadsheet or lots of individual properties shown on a map, and we're trying to mask that complexity and show the results back out in a simple way here. So you go into the web page and you type in a postcode, gives some information about what this is all about, and it goes off and finds your address, and then queries the information tagged against that property that we've seen previously on the previous screenshots, and pulls that back into what's hopefully a relatively easy to understand set of information. It looks at solar energy, solar hot water, and energy efficiency, again, which I don't personally know an awful lot about in terms of the domain. But what it's doing is trying to get the general public engaged in the potential of their property for solar panels, whether they be PV or thermal, or what energy measures they might be able to take on their property. And if they think it's something they're interested in, they can then go and talk to the council in more detail. And because all the information is sort of pre-created for the user here, they don't have to go in like some sites where you have to type in lots of information about whether your roof is south-facing or not, how big it is, where it is, etc. That's already been created for you in the background. And as you go on the different tabs here on the screen, you get different sorts of information displayed. And the energy efficiency is some sort of pre-created ideas of how you might improve the energy efficiency of that property. And as you choose one of these options, the figures get reflected back on the screen there. So that's displaying that what can be quite complicated information out in a fairly simple way, hopefully, to the general public. What we can also do with that same information is let the experts, or the planners in this case, look at that information in a slightly different way. Sorry, before I go into that, what we can also do is view it on a map and see where it might overlap with things like conservation areas or listed buildings, that sort of information as well. So disseminating the information to maybe more informed experts, there's a similar way we can do this. So this is a map. It's in a web-based application in Nottingham. You can zoom into any area of Nottingham, see the individual properties, and you might be interested in this particular area for whatever reason. You can draw around that area on the screen and essentially select those properties, those buildings that are in there. And once you've selected them, it then goes off and queries the information in the background to give you a summary report. And the sorts of things it will show in this case are summed up for that area, all those properties in that area. What's the potential around photovoltaic, thermal water, medium-scale wind? What's the energy that might be saved, therefore the CO2? What's going to have to be spent potentially to make the investment needed, and the likely paybacks? And there's also, whilst you've selected all those properties in that area, what's the likely take-up going to be in that area? Your gut feel, are 40% of the people going to take up the options in there? And you can alter the take-up there, and you get a report that's produced off the back of this as well. So it's helping to inform where you can begin to target certain measures. So in summary, we've got lots of different viewpoints as to where we can begin to invest in low carbon. We need to produce a strategy, work out financial appraisals, and consult with people and publicise. And we feel that by creating an evidence base that's based on a geographical approach, you can get a better insight at a macro but down to a micro scale of the sorts of decisions you've got to make. By using a geographical approach, you can begin to analyse the data in new ways that you can't do using traditional spreadsheets and databases, and hopefully make more informed decisions on the sorts of investments you've got to make. And that was it. If there's any questions, as I say, I can't pretend to be a low carbon expert, but if you're interested in the geographical approach, then please ask any questions or come and talk.